Hi everyone! In this video we are going to have a high-level view at the protection lattice that is implemented by Cisco AMP for endpoints to defeat modern advanced threats. My name is Evgeny Mirolubov and let's jump right into it. Cisco AMP for endpoints delivers visibility and control against malware and advanced threats across all attack vectors, going way beyond traditional point-in-time technologies. Protection capabilities built into the product comprise several engines that work together to prevent, detect, and eradicate threats. So if we look at that from the perspective of time to detection, one thing is obvious: the shorter this time is, the better. Because of that, let's start by looking at the in-memory prevention capabilities introduced by the product, exploit prevention and system process protection engines. Those are the two technologies added to AMP Windows connector starting with version 6.0.5. Exploit prevention engine defends endpoints from memory injection attacks commonly used by malware and other zero-day attacks. Those are the attacks on unpatched software vulnerabilities. Exploit prevention engine currently protects most common processes from being exploited, processes such as Microsoft Word, Excel, Outlook, web browser processes, TeamViewer, Microsoft Task Scheduler, and others. When it detects an attack against a protected process, it will be blocked and will generate an event. As a note, Exploit Prevention Engine is one of the technologies that has discovered the CCleaner backdoor. System process protection provides defenses to critical Windows system processes, such as Local Security Authority subsystem, Windows Logon application, Session Manager subsystem, and many others, by preventing compromise of these processes through memory injection attacks by other processes. If we look at the protection capabilities for files that went on the disk, we see several engines here as well. AMP Cloud provides access to the global intelligence database that is regularly updated and augmented with new detections. It offers a great breadth of knowledge to the AMP connector through one-to-one hash lookups, generic signature engine, and the machine learning engine, both point-in-time and retrospectively. Tetra is a traditional signature-based antivirus engine. It resides on the endpoint and provides on-the-disk detection capability. Custom detection serves the goal of providing robust control capabilities to the security administrator by allowing to define custom signatures and enforce blacklists. Malicious activity protection is one of the new engines focused at providing real-time protection against ransomware. That would block and quarantine the process that started the file encryption process. Finally, there is a robust endpoint detection and response component in AMP. It brings such capabilities as cognitive threat analytics integration, and this is used to identify and prioritize stealthy threats that bypass all of the other preventative technologies and that already operate in the environment. Device flow correlation serves as a triage knife, allowing to stop communications from the computer to known malicious hosts. And cloud indicators of compromise monitor malicious activity on the endpoint to alert if something suspicious has been observed. For example, a behavior where Microsoft Word launches PowerShell, or where shadow copies were deleted, which is a common sign of a ransomware infection. These engines are the foundation of the overall approach to pervasive advanced malware protection. While Cisco recommends to use all of these engines in conjunction with each other to leverage the full value of the product, customers can select whether to enable or disable one or another engine through a policy. While listed separately, these technologies work together as a protection lattice to provide improved visibility and increased control across the entire attack continuum. Next, let's review an example from the trenches. A recent outbreak of Samsom Ransomware that has been observed across multiple industries, including government, healthcare, and ICS. The initial vector for these attacks is currently unknown and is being investigated by Cisco Talos. What we know about this ransomware is that it's deployed using a loader which looks for a file with the .stubin extension, which is the actual ransomware sample stored in the encrypted format on the disk. Upon reading this file, the loader decrypts the payload with the password supplied as the first command line argument and executes it, passing the remaining arguments. Samsom Ransomware then searches for user files with targeted extensions and encrypts copies of such files, while removing the original files using Windows APIs. The new version of Samsom Ransomware doesn't include any changes to the encryption mechanism though. However, this new variant may use new file extensions for encrypted user files and ransom note files. There is a link to the Talos blog post that describes this attack in greater detail. So how can we apply AMP's protection lattice to defeat this type of threat? First of all, even though the initial vector for this case is unknown, once inside, an attacker may find many ways to move laterally if the components of the infrastructure are not patched or if common security practices are not followed. From M4Endpoint's perspective, we may apply exploit prevention and system process protection engines to defeat common techniques used for exploitation and propagation from one machine to another, either by stealing passwords or exploiting vulnerable applications. If the files land on the disk, we can use both the AMP Cloud Intelligence as well as the local signature-based AV engine to identify and block such threats. Unknown files may also be sent to ThreatGrid for additional static and dynamic analysis. On top of that, by enabling command line capture, we are able to see the command line arguments passed from the loader to the ransomware sample to decrypt the payload and execute. When further execution occurs, command line capture and cloud IOCs can provide visibility and fire an alarm upon suspicious behavior. Finally, in case we have seen a process that starts the encryption process, a cloud IOC would trigger, as well as malicious activity protection engine would block and quarantine this process to prevent complete encryption of all valuable files on the disk. Global file trajectory is also one of the key components that accelerates the ability to perform enterprise-wide incident response, and this is specific for a scenario where many machines got infected by providing a consolidated view into all of the affected endpoints. This revision accomplishes our high-level view of how we can apply the protection lattice implemented by M4Endpoints to a modern ransomware infection. Needless to say, applying basic security principles is an effective way of either preventing or seriously limiting the impact of modern threats, such as a recent Samsom Ransomware outbreak that we have reviewed. Let's have a look at a brief demo of the new Malicious Activity Protection engine that provides a generic way to identify, block, and quarantine processes that are associated with malicious activities. In the initial release, the focus is on ransomware, therefore we're executing a sample of Samsom, and in a few moments we see that this process is prohibited from running. To identify this malicious activity, we actually need to see it, which means that a couple of files would still get encrypted. M4Endpoints provides a clear view into the files that were affected before the process got blocked, so these files can be easily restored from backup. As a summary, M4Endpoints is an effective endpoint security solution that provides the capability to prevent attacks and block them in real time, detect threats through point-in-time and retrospective analysis, and support security teams by facilitating more streamlined incident response process, all within a single lightweight security agent. Thank you! I hope you enjoyed this video and I hope you take the most advantage of your M4Endpoints deployment.